So fine. I'm audible, right? My voice is clear and also my screen is completely visible. Okay. So we can start the session. I will, what is that? We'll start with this first question. Okay. So this is our 10th session, right? So fine. We have done with EM and we are in the middle of SOM. And after completing SOM, we will start our fluid mechanics. And also, I was planning engineering mathematics in between. Okay, right. And for your, what is that? For your reference, we have uploaded the test series corresponding to that is topic test. Just a moment. Yeah, topic test corresponding to engineering mechanics, engineering mathematics, fluid mechanics, thermodynamics, applied thermodynamics. Okay, yeah, applied thermodynamics. One more test is pending, and it will be available from tomorrow. Strength of materials. These subjects, all topic test and subject test was available. So once after completing the topics as per the schedule, I will recommend you to take the topic test and subject test. Please don't keep it until end. Okay. So previous year question and topic test, subject test. At least try to give topic test and one subject test. Okay. And then question bank. When it comes to question bank, mathematics 2 chapters are available, and fluid mechanics around 10 chapters was available. Okay, right. So what is my aim here? What is the aim which I wanted to convey is, don't only concentrate on the concept, concentrate on the problems also, which I was repeatedly saying from the different in a different videos, right? Okay, now let us start this session. I have waited for around 5 to 6 minutes, but anyways, let it be. We'll start the session. If any others wants to join, let them join in between. Okay, as usual, the rules are going to be the same. Okay, either you have to, if you want to ask your doubt, just raise your hand and unmute it and ask, or else if you want to comment it, you just comment it in the chat. Okay, right. So it's a very good question. A 280 mm cross 120 mm I section beam is to be used as a cantilever of a 3.6 meter length. Okay, so they said that it's an I section with a 280 mm and 120 mm I section beam. An approximate beam cross section is given here, but you could see that there was something in extra here. What is that? We will see it later. Okay, there was something extra here in both top and bottom. They said that it is a cantilever beam. Okay, it's a cantilever beam. It's a cantilever beam. Okay. And also they mentioned, you could see that, find a uniformly distributed load which can be carried by the beam if the permissible stress is 125 megapascal and I value, that is moment of inertia value of the cross section, is also given. See, first question, this is the first question, which is a very simple and a straightforward question. What they are asking? They are asking, we need to find out what is this UDL. What is this UDL value, W value, such that the maximum permissible stress is 125. Okay, sigma max is 125, and I value is 75 cross 75 into 6 10 to the power of 6 mm power 4. So first question is straightforward. Okay, you don't need to worry about anything. See, first, they are not including anything. Simply, it's an I section in which I is given, sigma max is given, and they are asking what is this W value, so that the maximum permissible stress doesn't cross this 125 megapascal. Okay, so first question is straightforward. Anyone can do it. Let me read the next question. That is, let me continue reading the question. Now see, if the cantilever is strengthened by 10 mm thick steel plates. Okay, see, until first question, okay, until this line, they are not saying anything about 10 mm thick steel plates, which means the red color shaded region which I shown you, okay, the red color shaded region which is having 10 mm thickness, there is no that plate which is present. Okay, there is no plate which is present until here. That means for first question, I'm not going to consider any extra plate. But now the second question, if the cantilever is strengthened by 10 mm thick plate, okay, so the thickness is given as 10 mm. Okay, let it be. Welded at the top and the bottom. As you could see that in the top also there is a plate and bottom also there is a plate. like top and bottom flanges to withstand 40% increased load. So now load, see, initially if load was W, now 40% increased. Okay, now the load is increased by 40%, which means what? If I add, understand this, if I had 10 mm above plate and 10 mm below plate, the load is getting increased by 40%. Okay, so which means W dash, that is the new load, will be 1.4 times of W. 40% increase means what? 100 plus 40, right? 140% of the initial value, so 1.4 of W. Okay, it is increased by, okay, increased, that is 40% increased load from, suppose initially if it is W, now it is 40% increase, so 1.4. If that is the case, that is now now 10 mm plate has been added at top and bottom, 40% increase. If that is the case, find the width of the plates, which means this B. They are asking about B. Okay, width of the plate, that is one question. And length over which the plate should be extended. This is something which is very interesting. Okay, such that the maximum stress being same. Okay, I will explain what does it mean. Length over the plate should be extended such that sigma max remains same. Okay, right. Now the first question is very simple. They are asking us to find out B. Okay, that is first question is very simple. I'm saying about the second question first part. Okay, second question first part is they are asking us to find out B. Okay, we can do it. Okay, the second question is little bit challenging. They are asking us to find out what is the length. See, if I take this is the cross sectional view, right? In cross section, at the top flange and at the bottom flange, I have two, what is that, thick steel plate, no issues. But if I see the side view, this is my side view, cantilever beam side view. If I see the side view, what is the length up to which this plate should be extended? Do I need to extend the plate completely? Okay, like this, or the complete length? Do I need to extend the plate? Or do I need to extend the plate only for some amount? Okay, only for some amount, and above that plate, we'll be having we'll be having the uniformly distributed load. So which one is going to happen? Okay, let me repeat it. We need to find out whether the complete, that is the steel plate, okay, the steel plate which is having a width of B will be placed over the complete beam, complete length of the beam, okay, or this is one case. If it is placed complete length of the beam, then I will be having my UDL here. Okay, I will be having my UDL here. If not, okay, if not, does it going to be like this? Like for some distance, I don't know what is the distance. We have to find out. Okay, that is the question. Okay, we need to find out this distance L, whether this distance L is going to be total length of the beam or this distance L is going to be less than that. I hope you got the point, right? So now I have explained you clearly what are all the things which they are asking you in the question. Okay, and now comes the challenging part, applying it. Okay, how I'm going to apply my concept for finding out all this data. Okay, right. See, the more important thing when it comes to this type of problem, see, anyways, this is a, what I could say, it's a little bit lengthy problem. They are not going to ask you directly this question in exam, but any part of this question and any interlinked question can be asked, and that is why it is always suggestible to go through these types of problems when we are preparing. Okay, right. So what I was about to say, first question we can solve it very easily, right? So they given sigma max, they given I value, they are asking what should be the W value so that sigma max is 125. It is not crossing 125. So what I can find out? How can I find out? We know the bending equation. The beam is going to get bended. We know that sigma b by sigma by y is equal to m by I. Okay. See, in this case, I'm not changing the I value, which is fixed. See, first case, I'm not introducing the plate. Okay, in the first case, there is no plate. Only I section was there. Okay, only I section was there. If you want more clarity, I will shade it down. Okay, this is, okay, this doesn't look good. Okay, only this section was there. Okay, only this section. First problem, only this section is there. Second problem, only I'm adding that extra plate. And I don't know what is the length at which I'm adding that, and also I don't know what is the breadth of that plate. Okay, now let us come back to the first case, that is this case. Here only this blue, yellow color shaded region is there, right? Only that region was there. Okay, now we already know what is y. see, one more thing. I'm going to take maximum. I'm going to take maximum what is that, bending stress, because they given maximum bending stress sigma b. Okay, and where maximum bending stress will occur, we know that very well, at the surfaces, right? Either at the top or at the bottom. Okay, topmost point of the flange or bottommost point of the flange. If I consider here topmost point or bottommost point, that's true. So sigma b is simply sigma max, which is given to us in the question. And if I'm going to consider sigma max, then y will be y max. That also we already know that. Okay, and I, it is given to us in the question. And what is my m? Which m I need to consider? See, they are asking us to find out if it has to withstand the sigma max, what will be my w? Am I right? So I need to take what is the maximum moment this beam can withstand. Okay, that is nothing but mr, which is moment of resistance or resistive moment. What is the maximum bending moment this beam can withstand? See, if I take this point, if I take a point here, moment will be 0. Obviously, it is 0. If I take this point, there will be some moment. If I take this point, there will be some moment. And where I will get maximum bending moment? At the fixed end. We all know this concept because we already studied SFT and BMD. I don't want to come back and discuss that. Okay, so maximum bending moment will occur here. So my rest, that is the maximum moment that the beam can resist, is nothing but our M max, and that will, sorry, yeah, M max, and that will occur at the fixed end. Okay, that will occur at the fixed end. We already know length is how much? Length is 3.6, which is given to us in the question. Okay, here is given. Now, if I want to find out this, if I want to find out moment at this point, what I should do? First, I need to draw the free body diagram. Not free body diagram. First, I need to convert this, convert that UDL into point load. W is the UDL or the complete length L. You take it as the complete length is L. Okay, then W L square by 2, and it will, sorry, W into L, that is our area, W into L, and it will exactly act at L by 2 distance. Okay, it will exactly act at L by 2. And if I want to find out moment at this end, that will be equal to WL into L by 2, that is WL square by 2. Okay, so maximum bending moment, which is nothing but the maximum moment the beam can withstand, the moment of resistance, that is equal to WL square by 2. Okay, and W we don't know, but L we know, right? What is L? L is 3.6, right? L is 3.6. So W into 3.6 square by 2. Okay, solve it and get the answer here. Okay, so what is the moment I need to consider here? The moment is MR. Okay, now substitute every value. 125, I'm substituting it in megapascal. Since I'm substituting sigma in megapascal, Y should be in what is that? Y should be in mm. Okay, Y max should be in mm. And what is my Y max? See, for the first case, don't consider the top plate and bottom plate. Only consider the I section, that is the yellow color shaded region. So Y max from neutral axis to this point. Okay, from neutral axis to this point. That's nothing but what? The total depth is 280 mm, right? Total depth is 280 mm. So this is 140. Okay, this distance was 140 mm. Okay, 140 mm. And that will be equal to moment of resistance. We will get it from this. Okay, I will just write it down here. Take your calculator and solve this and say me the answer by 2. And what is I? I is 75 into 10 power 6. Yes, anyone? Solve it and give me the answer. Those who are presently in the live. Okay, so solve it and give me the answer. Yes, 103.339. Gabriel answered it is 103.339. Okay, so 103.339. I will be getting the answer. Okay, one second. Actually, we did one mistake here, right? I taken everything in terms of mm, but length in terms of meter. Okay, I'm sorry. Gabriel, please correct it. I'm sorry. Okay, length I have taken in meter. That is the mistake. This 3.6 into 10 power 3 whole square. Okay. See, I have taken everything in mm, so length should also be in mm. Okay, that is my mistake. Correct it. Correct it. Correct it and give me the answer. Just with your answer, we need to multiply 10 power 6. You took in mm only. Okay, okay. You took in mm only. So you got 103.339. Okay. 103.339 Newton per mm, right? Yeah, Newton per mm. So if I want to convert it into meter, then I will multiply with 1000. So it become 103. Still, the answer seems to be wrong, Gabriel. Okay, I will give you the answer. You just cross verify it later. Okay, because as I said already, I'm not concerned about the answer or calculation. I'm more concerned about the approach, how we are approaching the problem. So you solve it and get the answer correctly. You will be getting 103 and yeah, 34 Newton per meter. Okay, in Newton per meter, you'll be getting like this. If it is Newton per mm, it is 10.334. Okay, 10.334 Newton per mm. Okay, so we are done with the first question. Okay, first question is done. Okay, but first question is very simple, as we know already. Now let us move for the second question. That is very important. Okay, now second question as concerned. This is first question. Okay, the second question as concerned, we understood that by including the 40%. See, what will be my moment? Okay, let me just get that answer also. What will be my moment? If I put W is equal to this, okay, here my moment will be MR will be 10334 into 3.6 square by 2. Okay, so that will be my moment of resistance. Any answers, or I will directly give you the answer. Okay, so you will be getting 66.964. Okay, 66.964. That will be your moment of resistance. Okay, so take it. That is, you just keep this. This will be in terms of Newton meter. Okay, this will be in terms of a Newton meter. Yes, that is moment of resistance, right? Okay, so here this is our first part. Let us keep that first part away as of now. Whatever I did now, I have just taken a I section, and for that I section, for withstanding this maximum stress, what is my the distributed load, and what is my moment of resistance? That is what I have calculated. Now coming to the second question. Yes. Now coming to second question, here the load is getting increased by 40%. So my W dash is nothing but 1.4 times of W, which is 1.4 times of, already I have a W, which is 10334. Okay, so if I multiply this, if you have a calculator, you just solve it and get the answer. Okay, if I multiply this, I will get W dash. And now next is what I'm doing. I'm adding an extra plate at the top and the bottom. So my new Y max will be, okay, what will be my new Y max? From neutral surface to the topmost point, which means this point, right? To this point. So already 140 and we have 10. So 140 plus 10, which is 150 mm. So our new Y max, I will take it as Y max dash, which is 150 mm. So now I got W dash and Y max. And what is the question? What is the question? Let me read the question again. They're asking us to find out the width and also length over which the plate is extended, such that the maximum stress being the same. Okay, we need to maintain the maximum stress to be same. Okay, that is what the question is. I should not change the stress value. So sigma max should still remain 125 megapascal. Okay, sigma max should still remain as 125 megapascal. Any answers for W dash? Any answers for W dash? No answers. Okay, I'll give you the answer. Okay, 1.4 into 10334 will be 14468. Okay, 14468. 14468 Newton per meter. Okay, in terms of Newton per meter, it is 14468. If you want it in terms of mm, you can convert it, no issues. Now we got, they said very clearly that our y max, now our y max is 150, the sigma max is 125, and the load is increased to 14468. So what will be my maximum bending moment, or in other words, what will be my moment of resistance corresponding to this load? Okay, which means w dash l square by 2. Initially it was w l square by 2, but now the load has increased, so it is w dash, that is 14468, into length was same 3.6 by 2. How much it is? Okay, calculate it. I'm doing it, I'm substituting everything in terms of, this is in terms of Newton per meter, this was meter square, so final answer will be in terms of Newton meter. Okay, final answer will be in terms of Newton meter. Now by increasing the load, I got my new moment of resistance and I got my new y max, but sigma max should not change. That is what the question is. Sigma max should not change. By keeping these conditions, I need to find out the b value. B is nothing but what? B is nothing but the width of that particular plate which I added. Okay, how can I find out? I can find out if I know what is my I value. Okay, so what will be my high value? As usual, sigma max, sigma by y, right? Sigma max by y max is equal to mr by I. This is I dash, that is new I after adding the plate at top and bottom. So I dash will be equal to sigma max by y max into mr. Okay, so sigma max value, which we already know, 125 by y max value 150, and m max, that is moment of resistance, you will be getting it as 93750. Okay, 93750 Newton meter, which is nothing but 93.75 Newton. Sorry, I have to multiply with 3, right? Okay, if I multiply with 3, okay, if I multiply it with 3, 1 meter is equal to 10 power 3. So 93.75 into 10 power 6, okay, 10 power 6 Newton mm. I am just multiplying it with 10 power 3, so it becomes Newton mm. So 93.756 into 10 power 6 Newton mm. Okay. Now what happens? What is my moment of resistance? I'm substituting everything in Newton mm and mm. Okay. So moment of resistance is 93.75 into 10 power 6. Now solve this. You will get the new I dash. Okay, you'll get the new I dash, and the new I dash will be in terms of mm square, mm power 4, because everything has been substituted. This has been substituted in Newton per mm square, and this has been substituted in Newton mm, and this has been substituted in mm. So solve everything, you will get I dash. Yeah, solve it and give me the answer. Hmm, 8.8 into 10 power minus 9. No, it is wrong. Somewhere some mistake was there. How it is 8.8? 1 second. I done any mistake here? Oh, I'm sorry. Actually, I did a mistake here. It is y max. It will come this, like, exactly opposite. Okay, it will be exactly opposite. That is mr into y max by sigma max. See, I cannot be in 10 power minus 6. That is that is highly logical. I is moment of inertia. It cannot be in terms of 10 power minus 6. Okay, so mr value substituted, y max value 150, and sigma max value is 125. Now solve it and get the answer. Yes, fast. 5,000. No, second, there you are doing some mistake. I don't know where you are doing the mistake, but surely you are doing mistake. MR is 93.75 into 10 power 6. Y max 150. Okay, and sigma max is 125. You'll get the answer in 10 power 6. Okay, in 10 power 6. I'll give you the answer directly. It is 112.5 into 10 to the power of 6. Okay, so 112.5 into 10 to the power of 6. See, remember one logic. Okay, what we have done. Okay, what we have done, we have added an extra plate at the top and the bottom. By adding extra plate at the top and the bottom, we have increased the moment of inertia, right? So moment of inertia surely should be more than that of the 75 into 10 power 6, because initially 75 into 10 power 6 is only for the I section. Now I have added an extra plate at top and bottom. So I dash should be surely greater than that of I. There is no doubt about it. We cannot get 5,000 or we cannot get the answer in terms of 10 power minus 6. Okay. So I hope this logic will help you in correcting the mistakes. See, your calculation mistakes will happen, and you should be ready to identify that is a mistake. Okay, those things can be done only by observing it a little bit more. I'm adding plate at the top and the bottom. So obviously I dash has to be greater than that of I. Moment of inertia, new moment of inertia should be greater than old moment of inertia. No doubt about it. So I dash is 112.5 into 10 power 6. And what is our I? It is 75, right? 75 into 10 power 6. So now what have we done? By adding the extra plate. Okay, by adding the extra plate, I have increased the moment of inertia. So how much I have increased? That increase in the moment of inertia, delta I, is nothing but I dash minus I. 112.5 minus 75. So that is 37.5 into 10 to the power of 6 mm power 4. And now see, this increase in the moment of inertia, just answer this, just try to answer this question so straightforward only. This increase in the moment of inertia has happened because of what? It has happened because of this plate only, right? The moment of inertia has increased because of this plate only. Okay, that increase has happened because of that plate only. So if I able to find out what is my moment of inertia for this plate alone, okay, for these two plates alone, extra plate. So for these extra plates alone about the neutral axis, that moment of inertia of plate alone, okay, I'm saying that moment of inertia of the plate alone will be equal to this increase in the moment of inertia. Let me repeat it. The moment of inertia has increased because of adding the extra plate. Okay, and now the increase in the moment of inertia will be nothing but the moment of inertia of the two plates alone. That's it. Okay, so now let me go back. This question is, as I said already, this question will be lengthy to explain, but we have no choice. We have to go through these types of questions. Okay. Yeah. See, if you consider the plate alone, I can easily find out about its centroidal axis. Okay, let me erase it. See, I can find out moment of inertia of this plate alone about the centroidal axis, about this axis. About centroidal axis, it is very easy for me to find out, but I want to find out about this axis, neutral axis, right? Not about the centroidal axis of this plate. But first of all, what is going to be that moment of inertia? It is simply b d cube by 12. So b into 10 cube by 12. But this is about this axis, the red color axis which I showed you. Okay, this is about this axis. But I want to find out about neutral axis. What I should do? What I should do? Answers? See, there was only 3 students. So if you don't answer, then I will feel bored. Okay, that is how it happens. Actually, I was expecting many of them to attend the class if I keep the session in Saturday. Okay, let it be. I don't want to discuss. I don't want to talk about it. Yes, what I should do? I know about moment of inertia about this. What is that? Moment of inertia about this axis. I want to find out moment of inertia about this axis. Okay, about this axis. What I should do? Parallel axis theorem, right? Parallel axis theorem, I have discussed that in mechanics, and also I have discussed it in strength of materials also. Simply use parallel axis theorem. I know about this axis, let it be h. I want to find out about this axis, let it be xx. What I will do? Ix will be equal to IH plus A into h square. H is nothing but the distance, okay? So distance between this and this was 145. How it is 145? See how it is 145. We know already. Okay, we know that this distance was 140. Okay, we know that this distance was 140 because I section was 280 and this was 10. So half of that was 5. So 140 plus 5 is going to be 145. That's it. Okay, so this is the moment of inertia, high h, and area. Area is what? Area is how much? B into 10. Okay, area is B into 10 and multiplied by h square. H square is the distance, which is 145 square. So this will give me moment of inertia of one plate alone. Okay, this will give me moment of inertia of one plate alone about the neutral axis. But I want for two plates, so multiply it with 2. Okay, so finally, moment of inertia of B. Okay, the plate. Okay, the extra plate about neutral axis is nothing but 2 times of B into 10 power 3 by 12 plus B into 10 into, what is that, 145. Yeah, 145 square. Solve it, you will get IB. But what I will be getting? I will be getting IB in terms of B, right? B multiplied by some number. That is what I will get if I take B commonly from this. Okay, if I take B commonly from this and this, if I take B commonly from this and this, I will get B multiplied by some number, right? I will give you that value also. Solution, you solve it later. Okay, how much is that? That you will, that is whatever, okay, whatever you are getting, B into some number. Okay, this is nothing but what? Moment of inertia of B about neutral axis. That should be equal to what? That should be equal to the increase in the moment of inertia. I will repeat this point again. The increase in the moment of inertia is nothing but due to the extra plates which I'm adding. So that extra plate, the moment of inertia of that extra plate is nothing but the increase in the moment of inertia, which is 37.5 into 10 power 6. And solve this, you'll get B. See, the logic is important. Okay, the calculation and all, I'm leaving it to you. Okay, because you have to learn it. You have to struggle with the calculations. Okay, so solve it. If I take everything in terms of mm, I will get it as 89.1 mm. Okay, so that will be my B value. Right? Any doubt? We have solved. We are done with 1 and we are done with second case, first only. Still we are left out with one more. Okay, still the problem is not done. Still we have one more thing to discuss. Any doubt until now? Okay. Fine. Now the next question is, see, we already calculated from this, we already calculated what is my width of the plate so that my sigma max remains same. Okay, so that my sigma max remains same. See, I can add, if I want, I can add this plate. I can add this plate to the entire, sorry, to the entire length. But it is not necessary. Why it is not necessary? Because until some length, the plate itself will able to withstand. Okay, how I am saying it? Listen, let me do one thing. Okay, so let this be my plate, and this is the new load. Okay, new load W dash. What is my W dash? What is my W dash? 14,468. Okay, that is my that is my W dash, 14,468 Newton per meter. If I want to write it in terms of mm, it is 14.468. Okay, Newton per mm. Okay, right. Now, initially, what is our W? Initially, what is our load? Initially, our load was something, I forgot the value. 10334. Okay, initially it was 10334. Initially, our W was 10334. 10.334 Newton per mm. When we had 10.334 Newton per mm, our maximum moment, okay, our maximum moment mr was equal to how much? It is equal to something like sorry again. 66.964. Okay, here it is 66.964. 66.964 Newton meter, which is nothing but 66.964 Newton mm. 6694 is in terms of mm or meter? Okay, it is in terms of Newton meter. Okay, correct only. Okay, I'm sorry, I just got confused. Now say our maximum moment, that is the resistive moment. This is the maximum moment. This is the maximum moment. This is the maximum moment this beam can withstand. That is the beam which is having a depth of 280. Okay, the beam which is having a depth of 280 mm. That is only with the I section. Only with the I section. This is the maximum moment the beam can withstand. Okay, this is the maximum moment the beam can withstand. Now I have increased the load. So when I should increase that cover plate, that is where I should put the cover plate. Simply put the cover plate where the moment is crossing this value. See, the moment was, the maximum moment was 66964, right? Until this point, still this plate can withstand this moment. Until this point, still this plate can withstand this moment. But when the moment crosses this value, you have to put the extra cover plates. By using that extra cover plates, I can make sure that the stress was not crossing the maximum value. Let me repeat it again. See, this plate, the maximum stress was 125 megapascal. For maintaining this maximum stress of 125 megapascal, the maximum moment, the resistive moment, that is the beam can resist a maximum of 66964 Newton meter, and that is occurring at a distance 3.6 meter. When initially when the load was 10.334 Newton per mm. Okay, but now I have increased the load. So as the load is increased, obviously moment is going to increase. Okay, moment is going to increase. So now if I measure moment at this point, mr dash, that's obviously going to be greater than that of this mr, right? But now this beam cannot withstand this mr dash. Why it cannot withstand? Because this beam, that is only with I section, it won't able to withstand, because only with I section maximum it can withstand 66964 only. So for withstanding more moment, I need to add more more cover plate. That is, I need to increase the moment of inertia, but I should not increase for complete length. What is the reason? Until the moment was 66964, there is no need for you to increase the increase the moment of inertia. What I meant, I will say here. Suppose let us consider at a distance x. Okay, from right support at a distance x, let us consider the moment was reaching 66964. Find out this x value first. Okay, find out this x value first. How can I find out? We know. Okay, we already know W into x dash square by 2 is nothing but m. Okay, because at a distance x, right, I will convert this distributed load into point load. I will get a center, that is W dash into x, and this distance was x by 2. So W dash x into x by 2 will be W dash x square by 2. Okay, that is my moment. And that we already know 66964. Now calculate W dash. Okay, this is W dash. From this I can find out x. Anyone? Just bring this to this side. X value was I'm substituting it in Newton meter. X value you will be getting it in meter, and W value is 14468. Okay, 14468. Find out X value. Answer. Substitute it and get X value. Yeah. 3.042. Fine, Gabriel. 3.04. Correct. 3.04. Now listen. Now just listen. Stop calculating it. See, until 3.064. Okay, until 3.064. With the same cross section itself, which means with the same I section. Okay, with the same I section itself, I will able to withstand the stress of 125 megapascal, because at 3.04 only the maximum moment is reached. Okay, so until that point this beam can resist. The beam can resist the moment. But once we cross this, the moment is increasing. So after that, the beam cannot withstand. Okay. So what I should do, I need to add a plate only here. An extra plate will be added only at this position. Okay. Only at this position. Okay. The extra plate. This is side view. Okay. This is side view. Front view, I already showed you. Okay. Where it is. This is my front view. This extra plate. Okay. This extra plate is going to get added only for that length. How much is that length? We already know the total length was 3.6. This was 3.04. So 3.6 minus 3.04 is 0.56. 3.04, right? Yeah, 3.04, 0.56 meter. So only this section, that is only the section of 0.56 meter, the beam cannot withstand the extra moment. So only during that period, that is only during that section of the beam, I need to increase the moment of inertia. So I'm increasing the moment of inertia so that its moment resistive capacity is also increasing. Okay, moment resistive capacity is also increasing by maintaining the sigma max value. I'm not changing the sigma max value. You need to understand the sigma max remains, maximum stress developed remains same, but the resist, if it has to resist more, okay, if it has to resist more load, the moment resisting capacity should increase. For increasing that moment resistive capacity, I'm adding the extra plate. But until this point, that is over this complete beam, the moment, that is the maximum moment which we are getting, was less than that of 66964. At this point only, okay, at this point only the moment is reaching 66964. So until this, I can add, there is no requirement for me to add the plate, extra plate. Okay. That is why I said this question has lots of layer and it's a very good question. So what is the L value? It is 0.56 meter. Okay. So any doubts? So any doubts? If there is no doubt, or else you take 1 or 2 minutes, then observe it properly. Clear. Okay. Okay. Fine. Fine. Good. It's a very good question. Okay. But as I was saying already, I'm doing these types of questions because of last year. Everyone know what happened in last year. There was some good questions which is asked. Yes, Gopi, you can ask your doubt. Yeah, ask your doubt. You can ask. how comes L? How that L value? Okay. See, that is what I was explaining it, but it's nothing actually. See, okay, okay, here it is. I will say it. I will say it little bit slowly. Okay. Anyways, தமிழ் தானே இருக்கீங்க எல்லாரும் மூணு பேருமே தமிழ் தான், so no problem. ஸோ இங்க பாத்தீங்க அப்படின்னா வந்து இந்த பீம், ஓகே, இந்த பீமோட ஐ செக்ஷன் வந்து நான் இந்த அதே ஐ செக்ஷனை நான் மெயின்டைன் பண்ணேன். ஓகே, அதே ஐ செக்ஷனை நான் மெயின்டைன் பண்ணேன் அப்படின்னா இந்த பீம் வந்து இந்த பீம் 66964 அந்த வேல்யூ ஆஃப் மொமெண்ட் வரைக்கும் இதால வித்ஸ்டாண்ட் பண்ண முடியும். ஓகே, ஐ செக்ஷனை நான் சேஞ்ச் பண்ணலனா. ஓகே, ஆப்வியஸா நான் செக்ஷனை இன்க்ரீஸ் பண்றேன், அதாவது மொமெண்ட் ஆஃப் இனர்ஷியாவை நான் இன்க்ரீஸ் பண்றேன். எப்படி நான் இன்க்ரீஸ் பண்றேன்? மேலேயும் கீழேயும் எக்ஸ்ட்ரா பிளேட்ஸ் வச்சு. ஓகே, ஸோ நான் மொமெண்ட் ஆஃப் இனர்ஷியாவை மேலேயும் கீழேயும் எக்ஸ்ட்ரா பிளேட் வச்சு நான் இன்க்ரீஸ் பண்றேன் அப்படின்னா நான் ஏன் கம்ப்ளீட் பீமுக்கும் பண்ணணும்? ஃபர்ஸ்ட் ஆஃப் ஆல் நான் கம்ப்ளீட் பீமுக்கும் பண்ணேன்னா என்னோட வாட் இஸ் தட்? இட்ஸ் அ வேஸ்டேஜ் ஆஃப் மெட்டீரியல், இட்ஸ் நாட் எக்கனாமிக்கல். ஓகே, நான் அது தேவைப்படாது. ஏன்னா ஒரு பர்டிகுலர் செக்ஷன் வரைக்கும் அப் டு சம் பர்டிகுலர் செக்ஷன் மொமெண்ட் வந்து இந்த 6694 கிராஸ் பண்ண போறது கிடையாது. அன்டில் 6694 இந்த பீமால வித்ஸ்டாண்ட் பண்ண முடியும். ஓகே, இந்த பீம் அதாவது சேம் ஐ செக்ஷனால வித்ஸ்டாண்ட் பண்ண முடியும். ஸோ நான் என்ன பண்றேன் நெக்ஸ்ட் ஸ்டெப்ல, இப்போ நான் லோடை இன்க்ரீஸ் பண்ணேன்னா, ஓகே, நான் லோடை இன்க்ரீஸ் பண்ணாத வரைக்கும் ஃபிக்ஸ்டு சப்போர்ட் பிளேஸ்ல தான் வந்து எனக்கு 6694 ரீச் ஆகிறோம். ஓகே, பட் நான் லோடை இன்க்ரீஸ் பண்றேன் அப்படின்னா ஆப்வியஸா ஏதோ ஒரு பிளேஸ் இன் பிட்வீனே வந்து இந்த 6694 நம்ம ரீச் ஆயிடுவோம். ஓகே, இந்த 6694 நம்ம ரீச் ஆயிடுவோம். நான் அந்த பாயிண்ட்டை தான் நான் கண்டுபிடிக்க ட்ரை பண்றேன். ஏன் அந்த பாயிண்ட்டை கண்டுபிடிக்கிறேன்? இந்த 6694 முன்னாடி வர இந்த கம்ப்ளீட் பீம்ல நீங்க எந்த பாயிண்ட் வேணாலும் எடுங்க, எந்த பாயிண்ட் வேணாலும் எடுத்து மொமெண்ட் கண்டுபிடிங்க. அந்த மொமெண்ட் வந்து இந்த 6694ஓட கம்மியா தான் இருக்கும். ஸோ அப்ப இந்த பீம் நான் அதே ஐ செக்ஷன் வச்சா கூட, நான் பிளேட்டை வந்து மேலே கீழே பிளேட் வந்து எக்ஸ்ட்ராவா ஐம் நாட் ஆடிங் எனி எக்ஸ்ட்ரா பிளேட் அட் டாப் அண்ட் பாட்டம், ஸ்டில் த பீம் கேன் வித்ஸ்டாண்ட் தட் மொமெண்ட். பட் ஆனா ஒன்ஸ் நம்ம இதை தாண்டி போயிட்டோம் அப்படின்னா மொமெண்ட் இன்க்ரீஸ் ஆயிடும். ஸ்ட்ரெஸ்ஸை இன்க்ரீஸ் பண்ணாம, ஸோ நம்மளோட ஏம் என்னன்னா ஸ்ட்ரெஸ் இன்க்ரீஸ் பண்ணக்கூடாது, ஸ்ட்ரெஸ்ஸை இன்க்ரீஸ் பண்ணாம அதை வித்ஸ்டாண்ட் பண்ணணும். ஓகே, அஃப்கோர்ஸ் நான் இதை தாண்டி போயிட்டேன்னா இந்த பீம் வித்ஸ்டாண்ட் பண்ணலாம், பட் ஆனால் ஸ்ட்ரெஸ் வேல்யூ இன்க்ரீஸ் ஆயிடும். ஓகே, நான் ரெண்டு கேஸ்லயுமே வந்து ஸ்ட்ரெஸ் வேல்யூ இன்க்ரீஸ் ஆகக்கூடாது அப்படின்றது தான் கண்டிஷன். ஸோ நான் இதை தாண்டி போகும்போது இந்த பீம் அந்த மொமெண்ட்டை வித்ஸ்டாண்ட் பண்ணணும், அட் த சேம் டைம் ஸ்ட்ரெஸ் இன்க்ரீஸ் பண்ணக்கூடாது. அப்படின்னா இந்த செக்ஷனுக்கு மட்டும், அதாவது வெறும் அந்த 0.56 மீட்டருக்கு மட்டும் நான் எக்ஸ்ட்ரா பிளேட் ஆட் பண்றேன். பேலன்ஸ் இருக்கிறதுக்கு நான் ஆட் பண்ண வேணாம், பிகாஸ் என்னோட மொமெண்ட் 6694ஓட கம்மியா தான் இருக்கும். அவ்வளவுதான் லாஜிக். ஓகே, கிளியர் கோபி? So எனக்கு ஒரு question taken 1 hour. Oh, I know this question will be lengthy, but ஆனா இவ்வளவு நேரம் எடுக்கும்னு நான் எக்ஸ்பெக்ட் பண்ணல. Okay, yeah, go through this question. Okay, we'll continue with this question. A cantilever beam of length 31. Oh, sorry, this 3L. Sorry, this 3L. Okay, 3L is subjected to two forces, each of magnitude P. So there is a force P, there is another force P. The flexural rigidity of the beam is EI. Assume linear elastic material and small deflection. Okay. The first question is, which one of the following statement is true? The magnitude of the bending moment in the portion AB is 0. The magnitude of bending moment in the portion is PI is 2 PI and 0 to PI. Okay. See, they are asking about what is the bending moment in this section. Okay, in this section AB, right? Yeah, in this section AB. So obviously, if I draw the, what is that, SFD and BMD, the problem will become very simple. Okay, so here load is P, here load is P. See, if this load is P, this load is P, what will be my reaction? Automatically, summation of F will be 0. P minus P plus R, reaction will be 0. So automatically R will become 0. Okay, so reaction was 0 at the fixed end. The fixed end reaction was 0. Okay, and what about the moment? If I want to find out moment, P into L, which is acting in clockwise, and P into 2L, which is acting in counterclockwise, plus moment at this point. I will take moment as counterclockwise, right? Counterclockwise. Okay, moment is counterclockwise. Moment at this point, which has to be equal to 0. So M will be equal to minus PL. Okay, I'm getting minus PL. So moment was not in counterclockwise direction, it was in clockwise direction. I'm not spending much time on this because how to find out reactions and all, we have done number of questions in course itself. So it is not needed to be discussed here. Okay, I'll just proceed for the problems. So we are done with the reaction. So how will be my SFD, shear force diagram? At this point, there is no reaction. Okay, at this point, there is no reaction. It is 0. So yeah, at this point it is 0. So from here to here also there is no moment. So there is no increase or decrease in the shear force diagram. But here there is a load P which is acting down. Okay, and then it is a 0 slope, and again load P acting up, and then again it's a 0 slope. Okay, so we got shear force only between this region. Okay, only between this region. And now what will happen to bending moment? So at this point, a moment of M into L is acting in which direction? Clockwise. Clockwise means it will shift upward, right? Bending moment clockwise means it will shift upward. So M into L. And now between this, we know dm by dx equal to V, and we know V was 0. Okay, so slope is 0. So 0 slope in the sense it's just an horizontal line. Okay, just an horizontal line. And after that, here there is a load alone. There is no moment, so there won't be any shift. And now between this point also 0 slope. So again it's a straight line. And again between this and this also it's a 0 slope. Again it's a straight line. I'm sorry, I have done some mistake. Oh, okay. I'm sorry. Yeah. So here we have negative, right? Dm by dx is equal to V, which is what? Negative and constant. Okay, negative and constant. Shear force was negative and constant. Okay, shear force was negative and constant. Here only shear force is 0. Here shear force is negative and constant. So negative constant means I need to climb down. Okay, negative constant, climb down, constant, which means a straight line. Okay, like this. And from here, again it's a 0. Again it's a 0, like this. Okay, so this is how I got my bending moment. Now, what about the question? See, these things, I hope there won't be any doubt. Okay, right? So in section AB, okay, in section AB, it is constant. That is nothing but not M into L. I'm sorry. It's P into L. It's not M into L. It's P into L. Okay, it is P into L. Okay, so it's constant and the value is equal to P into L. So that is option B. Okay, so that is option B. What will be my deflection at point B? How to calculate it? I hope everyone have done the deflection chapter. Okay, so there won't be any issues in that. I believe so. So how to calculate deflection at point B? See, it's a combined question. One question is basically from SFD BMD. Next question is from deflection. How to find out deflection at point B? What should I do? Superposition. just use principle of superposition. Transfer this load P to point B. Okay, if I transfer it, apply equal and opposite load here. Okay, apply equal and opposite load P here. Okay, if I apply equal and opposite load P, this load P and this load P combinedly gives me moment. Okay, that load P and this load P combinedly gives me a moment, and that acts in this direction. Okay, that is P into EL. Okay, and already there was a load. I have to add that, right? Or else we can, instead of doing that, okay, anyways, no issues. There was a load P. Okay, and there was one more load P here at the bottom. Okay, there was one more load at the bottom, so I can cancel these two loads also. So finally it will result in a beam something like this, P into L, and the distance was L. And now I want to find out what is that deflection at point B. See, what is this, what type of case it is? It is falling under which case? See, there is a point moment acting at one end. Okay, point moment acting at one end. Simply, this is the case. Okay, this is the case. The distance was L. Okay, if I want to find out deflection here, it is ml square by, what is that, ml square by 2a, right? Yeah, ml square by 2a, ml square by 2a. And in our case, moment is P into L. Okay, moment is P into L. So deflection at point B is ml square by 2 times of EI, which is m is what, PL. PL into L square by 2 times of EI. So that is PL cube by 2EI. And how does it act? Downward or upward? How it will be, downward or upward? Answer it, downward or upward? So what type of moment it is? Upward. Yes, Jagan, it is upward. It's a anti-clockwise moment, right? So it will bend like this. The beam will bend like this. It's an anti-clockwise moment, so upward. So PL cube by 2EI, which is option B. Okay, it's comparatively a simple question. Last question is lengthy, but this is comparatively a simple question. So I hope there won't be any confusion here. I'm simply using our basic of slope method for SFDBMD, and then what is that? Superposition for deflection. Fine. Yeah, next question. Go through this. Okay, so let us continue. The next question. This is basically from what is that? Just a moment. It's basically from strain energy. It's a simple question only. Okay, just 1 second. Got the answer. Strain energy in one spring is 3.9 into 10 power minus 4. 3.9, 10 power minus 4. I guess your answer was, you are close, but somewhere you did mistake in your calculation. 10 power minus 4 seems to be wrong. 10 power minus 7 again. Check your units. Okay, I guess somewhere you guys are doing mistakes in units. Okay, but the problem is very simple. We have already done some questions also related to this. Okay, so we'll start doing it. A load of 5 kilonewton is applied to the center of a 999 steel beam. Okay, they're given that this beam is a steel beam, and for which I is given. If the beam is supported on 2 springs, each are having stiffness, determine the strain energy in each of the spring and the bending strain energy in the beam. Okay, bending strain energy means the total strain energy. Okay, how can I do? So first I will draw the free body diagram for it. If I draw a free body diagram, a load of 5 kilonewton is acting at the center, and here I will be having a reaction, right? If I remove the spring, okay, if I remove the spring, let us consider this is my ground, let us consider this is my ground. The spring will offer a reaction, the spring will offer a reaction on the beam. Okay, the spring will offer a reaction on the beam, let it be Ra, and similarly the spring will offer a reaction on this beam, let it be Rb, and the beam will offer a reaction on the spring. Okay, we should not forget it. That will be equal but opposite, and because of that both the springs will get deformed by some amount. That is, it will get compressed by some amount. Let the compression be delta. Okay, let the compression be delta. Okay, now how can I, this delta, like how can I relate it? I can simply relate it. See, one thing we know that the load was acting exactly at the center 5 kilonewton. The load was acting exactly at the center 5 kilonewton, so I can split it. This will be 5 by 2, 2.5 kilonewton, symmetric, right? So this will also be 2.5 kilonewton. Okay, so both are 2.5. So from this I can say Ra is equal to Rb, which will be equal to my spring force in any one of that, like spring force in this and spring force in this, and that will be equal to what? K into delta. From the base formula we know that already. So K we already know, so delta will be nothing but what? Delta will be nothing but Fs by K, and Fs is nothing but 2.5. Okay, by Fs is 2.5, which is what? 2.5 into 10 power 3 Newton. Okay, and what is my K? K is the stiffness, which is given to us in terms of 8 meganewton. So 8 into 10 power 6. I guess I'm right. Fs has been substituted in terms of Newton, and this has been substituted. Okay, so if I solve it, I'll be getting my delta, and delta will be in terms of meter. You don't forget it, because I'm substituting everything in terms of, this is in Newton, this is in Newton, this is in Newton per meter, right? So everything in terms of Newton and Newton per meter. So delta will be terms of meter. Now, how to find out strain energy? See, strain energy of the spring, left side spring, or strain energy of the spring, right side spring, it will remain same only, and that is nothing but 1 by energy of the spring, right? We already know strain energy, or the energy stored in the spring, 1 by 2 K into delta square. We have discussed it in SOM itself. Sorry, engineering mechanics itself. So 1 by 2 into K value is 8 into 10 power 6 into delta, whatever value you are getting, square it, solve it, you will get the strain energy. Okay, strain energy for what? Strain energy for the springs alone. Okay, strain energy for the spring alone, I can get it from here. Yeah, Gabriel, correct. 3.39 is correct. Okay, 0.39 joule. I don't need much of an explanation here, so I guess very straightforward. And what I should do for moment, bending strain energy in the beam. I have done this question also in our course. What I should do? I have done this question. Simply supported beam. If I want to find out bending strain energy in the beam, so you just take a section. Okay, just take a section here. Basically, what is the formula? M square L by 2 EI, right? That is my strain energy formula. M square EI by M square L by 2 EI. But here the moment is variable. Okay, at this point moment will be 0, at this point different moment, at this point different moment. So at each and every point, if I take a section here, okay, if I take a section here, a distance of x, then moment at the section x will be equal to how much? RA into x. RA is already we know 2.5. Okay, 2.5 kilonewton. Converted into Newton, so 2.5 into 10 power 3 into x. So that is my moment. So moment is variable, so I cannot use this formula directly. Instead of that, I need to integrate it. Okay, so mx into dx, mx square into dx by 2ei. So these are basic formulas which I already discussed. And from where to where I need to integrate? See, this section xx is taken from this point, to this point only. Okay, again, if I want to find out bending moment in this section, okay, if I want to find out bending moment in this section, again I need to take another section. Okay, again I need to take another section x. I can do in that way, but what I can do the other way is, what is the other way? I can take another section, that is fine. I can take another section here, xx. Again I can find out what is my moment at this section x. Okay, again I can do that, and then I can find out. But instead, we know that, yes, as Jagan said, it is a symmetric. It's a symmetric, right? So this side section and this side section both are symmetric. So if I able to find out strain energy for, this side section, is simply for this side section, and if I multiply with 2, I will get the total strain energy. Okay, so simply from 0 to L by 2, L by 2 is how much? 3, right? 3 meters. At this point, it is 3. Okay, from 0 to 3, I'll multiply it with 2. Okay, so that I will get the total strain energy. If not, if you're not going to follow this, you take one section here first, xx, you integrate it from 0 to 3 first. Then you take another section here, okay, xx, find out moment at this section xx, and integrate it from x is equal to 3 to x is equal to 6. You should not integrate from x equal to 0. Okay, don't do that, because already this section's strain energy has been calculated. So now you are calculating only this section strain energy. So you need to integrate from x equal to 3 to x equal to 6 only. Okay, or else find out one half, find out this half, and multiply with 2 as I did here. Okay. So what will happen? This will be 2 times of integral 0 to 3 mx 2.5 into 10 power 3 into x whole square into dx, the whole divided by 2 times of EA. So EA can be taken out, it's a flexible rigidity. So EA 2, all can be taken out, 2 will get cancelled, EA can take it out, 1 by EA. And even that 2.5 into 10 power 3 whole square can be taken out. Okay, so x square integration is x cube by 3, upper limit is 0, lower limit, sorry, upper limit is 3, lower limit is 0. Solve this, you will get this total strain energy. Okay, just solve it and give me the answer. Okay, what's the answer? Sir, you don't need EI value. Just give the answer in terms of what is that? Numerator by EI. In exam, EI value will be given. You don't worry. Okay, in exam they will be giving you. Here you don't take EI value. Just put 1 by, that is 1 by EI and the numerator. Okay, fine. You can solve that. Okay, you will solve that and you will get the answer. There won't be an issue in that. So 9th question, 10th question, both are good one. Okay, I will stop the session now. We will continue it later. Out of this 3 questions, first question is something which is crucial, and again I will be discussing few more in the next week also. This is also one of the very good question, and this is also very good question. Okay, so we'll continue in the next session. That's it for today. Okay. Yeah, I will close the session. Yeah, thank you, Gabriel. Thank you all.